Good afternoon. Uh, Today we will start our next module. Is the today module is statistical data analysis, interpretation, and non-parametric test. So, what are the learning objectives? Today's session: discuss about the statistical data analysis, describe the details of testing of hypothesis and its basic concept, and discuss about parametric and non-parametric test. So first we are discussing what is statistical data analysis. Statistical analysis is the process of collecting and analyzing large volume of data in order to identify trends and develop valuable insights. In the professional world, statistical analytics take raw data and find correlations between variables to reveal patterns and trends to relevant stakeholders. So that means what happened? Now, when we analyze data, this data collected from the respondents. After raw data, how can you find out the better solution of the particular research work? So in here, what we will do? Now we have to use some statistical techniques to find out the best solution of our research study. So there are various types of statistical techniques are available. So we have to use appropriate techniques as per our requirement, as per our research design. Statistical data analysis refers to the analysis of data collected to derive patterns, trends, or other meaningful conclusions. It involves the use of statistical methods of data analysis. So that means what happens? Various types of analysis and various types of techniques we are using to use the data analysis to find out the better solution for new development or new investigation. So generally what happens in the statistical data analysis, we are used two types of data generally, descriptive statistics and inferential statistics, or we can say that statistical inferences. So this, what is the descriptive statistics for the statistical inferences? We will discuss one by one. So now, after statistical data analysis, why the statistical analysis is needed? To identify the patterns or the trends, or identify pattern and trends from the data. That is what? Data that may not be obvious to the human eye can be analyzed statistically to reveal patterns and trends. It aids in our comparison of the relationship between variables and how they evolve through times. So when you are collecting the data from the market or from the from the respondents, so when you are going for the analysis, at that time we have to identify the variable. Data means variables. Identify the variables. Whether the variables are being the relationship between them or not. If there is relationship of the variables are not more, that means your analysis conclusion or your conclusion should be less. So that means first you have to identify the relationship between the variables. Next one is make data-driven decisions. If the relationship between the variables are more, that means the decision you can take appropriately. Otherwise, it is very difficult. For example, I am giving that. When you are selecting the variables, suppose for example is that when you want to develop the quality education of any organization, at that time, what are the variables is required? The variables we can take from the students. That is quality of the teaching, one variables. Library facilities, another variables. Placement from the institute, another variables. Then these three, teaching, resources, and placement, three are more correlated. If you are considered with other than three, may be correlated, there may be correlation, there may not be correlation. Suppose you can say that industrial visit, international tour, or that is another one is you can say that seminar, workshop, like this. These are correlated, but more correlators are among the 6 variables. Which one? One is teaching, quality teaching, another one is facilities or resources, library facilities, and one is placement. These three is more correlated among other variables. Sometimes some institute they are doing for industrial tour or may not be industrial tour or industrial visit. Some institutes may do the international tour. Some institutes they may not be international tour. So like this, some institutes they are going for the seminar or may not going for the seminar. But in these cases, what happens? These three the variables are independent and also sometimes it will be dependent. So in our statistical analysis, what happen? Now make the data driven decision means which type of variables are more important, which type of variables are more important among all the variables. So this is very very important. The next one is evaluate the hypothesis. Hypothesis, why you are evaluating the hypothesis? Now the hypothesis is what happened. Now before you selecting any variables, before you selecting the any variables or before you selecting the any hypothesis testing, at that time you have to find out that your hypothesis is absolute or correct or not before you doing your analysis. So that means what happened? Now, if you are taking one statement, this statement is correct or not. First, you have to find out that you assess the hypothesis by comparing them the data. It enables us to assess the likelihood that hypothesis is correct or incorrect. So that means what happens? Suppose I am taking that the hypothesis is quality teaching are significant for to develop the quality education. Whether this statement is correct or not. Quality placement is a significant of to develop the quality education. It is a part of your hypothesis, your objective or not. So when you are taking the hypothesis always belongs to the objectives. As per the objectives, we are taking the hypothesis. So when you are taking hypothesis from the objectives, first you have to find out that whether this statement is correct or incorrect. So you have to find out if it is incorrect, we cannot go for the hypothesis. If correct, then we go for the hypothesis. Improve process. Statistical analysis enables us to pinpoint process improvement opportunities. Data analysis allow us to spot bottlenecks and insufficiencies and implement improvement that boost output and efficiency. So that means what happened? Now when we are going for the statistical analysis, at that time what happened? Now we have to find out the better opportunity of our research problem. So for that cases, what happened? Now we have to improve our bottleneck situation or any difficulties we are facing, any situation we can improve it, or inefficiency, you have to efficient it. Implement improvement that the implementation of the statistical analysis or when you are implementing that is hypothesis testing to improve the better solution. Predict future outcomes. Sometimes what happens, now we are unable to find out the future outcomes as per the research problem we are finding. So for the better predict future outcomes, we can use the statistical analysis. That means what happens? To forecast the futures. That means looking at historical trends and patterns, statistical analysis enables us to forecast future results. It lets us to determine the possibility that specific occurrences will occur and then base our judgment on that knowledge. So that means when we are using the statistical analysis, at that time what happened? It is better opportunity to the researchers or to the investigators to predict the future outcomes in positive manner. Then what are the type of statistical analysis? First one is descriptive statistics. The primary objectives of the kind of analysis are to summarize and describe a data sets, fundamental characteristics such as mean, median, and standard deviation. So descriptive statistics is generally what happens. Now you know in your statistical methods, descriptive statistics we are calculating measures of central tendency and measures of dispersion. In the measures of central tendency, we are calculating arithmetic mean or simply we can say that is mean. then median, then mode, then you can say percentile, decile, and also we can calculate in your that is what you can arithmetic mean and harmonic mean. These are the part of measures of central tendency. And measures of dispersion, we are calculating the range, interquartile range, mean deviation, standard deviation, coefficient of variations. So this part we are calculating in where the measures of dispersion. But in your statistical analysis, when you are using the descriptive statistics, so at that time, very important is mean, median, and standard deviation. These three is very important. Why it is required? Now, as per the formula of statistical or statistics or your statistical techniques, generally you are using mean, median, and standard deviation. These are more appropriate in the statistical analysis. Mean median is the average value, and this standard deviation is the deviation from the variables. Then inferential statistics. Inferential statistics used to derive inferences from data is known as inferential statistics. It entails using sample data to infer relevant information about the population the same was taken from. It used method including correlation, regression, and hypothesis testing. But when you are using the inferential statistics, then we are using the correlation, regression, and the hypothesis testing. In here, what happened? Now we are using these techniques to find out the better analysis of your data. Descriptive statistics only you are using the average value standard deviation, but in your information statistics you are using correlation, regression, and hypothesis testing. In correlation regression, generally what happened? Now we have to find out the relationship between the variables for all the data sets. That means those data we are collecting from the respondents or from the markets or from your research study, the data is correlated or not. If it is correlated, then we can find out the better solution. If not correlated, automatically your analysis is wrong. Analysis is not wrong, but you cannot find out the good solution. Similarly, how can you find after relationship or between the relationship between the variables, how can you find out the solution? Now after that you test it whether this relationship is acceptable or not. For that cases we are using hypothesis testing. Then another one is predictive analysis. The sort of statistical study called predictive analysis is used to point out or pinpoint prospective outcomes or trends. It entails the use of data mining tools to find patterns in data and the subsequent use those patterns for forecast the futures. Predictive analysis, simply what is predictive means you have to forecast it. When you analyze your data, so you have to forecast that whether tomorrow it will be rain or not, or day after tomorrow it will be rain or not. What is the weather forecast in between the 1 month? So at that time, what happened? We are using the predictive analysis. Some techniques, statistical techniques, we are using forecasting techniques there, or sometimes we can see the time series analysis or time series techniques we are using to forecast the values. So that means in predictive analysis, generally you are using the forecasting technique and to predict for the future. Then, what are the type of statistical analysis? Another one is regression analysis. Analysis that model the link between two or more variables is known as the regression. Regression analysis is widely used to predictive modeling to show how dependent variable is related to one or more independent variable. Similarly, correlation analysis also, same thing, same pattern is there. That is, whether your solution, whether your variable, whether your dependent independent variable are more relation between them or less relation between them, you have to predict it. For example, that in which cases you are using regression analysis. Now suppose that you have to find out your demand as per the input or resources. As per your resources, first you have to find out that your demand is more or demand is less. You have no idea about the demand. You have no idea about the resources. So you have to find out that whether your demand is more or demand is less. So at that time, what happened? So the regression line, you can use the regression analysis. You have to find out the better prediction values or predictive values from your data sets. Then another is multivariate statistical analysis. Generally, in this analysis, multiple variables can be used. Currently used multivariate statistical analysis. These are various techniques that are included multivariate analysis, and there are factor analysis, cluster analysis, and discriminant analysis. When the values are more than two variables, sometime in regression analysis, if the variable is more than two, then this is called the multiple regression. In your correlation analysis, if your variable is more than two, this is called the multiple correlation. So when you are preparing the two variables cases, this is called partial correlation. So that means what happens in your correlation and regression, when you find out the relationship between the variables, that time it is called the simple variable or simple correlation or simple regression. But if your more than two variables are we are calculating or we are considering, then this type of analysis is called multiple correlation or you can say multiple regression. But same cases 3, 4, 5, 6, 7, 8. So this is very difficult to identify and this is very difficult to analyze your data. So for that cases what happen? Now we are using multivariate statistical techniques or multivariate statistical analysis. From this multivariate statistical analysis, generally you are using factor analysis, cluster analysis, discriminant analysis, and also the causal analysis also there. So this type of analysis where we are using, so this is called a multivariate statistical analysis. Okay. So now question is that what are the methods of statistical data analysis? What are the methods? So already we are discussing that. So we have to find out the mean values. We have to find out the median values. We have to find out the standard deviation for the descriptive statistics. And for the informational statistics, generally we have to find out the values, correlation values, and the regression values. After that, we test the hypothesis whether these values are correct or not correct. Clear or not? Now, what methods we are taking in the statistical analysis? First one is mean. Mean is commonly used measure of central tendency in statistical data analysis. It represents the average value of set data and calculated by summing all the values in the data set by dividing the number of observations. Yes or no? So when you find out the values, suppose the value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the mean values? Now up to you add up to 10 divided by number of items. Suppose you find out the mean values of 3 and 2. So 3 plus 2 by 2. This is the average values or not? So mean you can say that this is the average value. The mean is useful measure when the data is normally distributed and the outlier do not significantly affect the overall pattern of the data. So when mean is when calculating, so when data is normally distributed at that time we can find out the mean. If data is scattered, we cannot find out the mean. If data is not normalized, then it is very difficult to find out the values. Only when your data is normally distributed, then only we can find out the mean value. Otherwise, we cannot find out the mean values. Then second one is regression values. What are the regression values or what is the regression? The regression analysis is a statistical method used to model the relationship between the two or more variables. It is a powerful tool for predicting the value of a dependent variable based on one or more independent variables. Because when regression analysis we are using, so at that time what happened? Now we have to need the two variables. One is dependent variables and one the independent variables. When you are find out the regression values, so at that time the dependent values depending on the independent values, dependent value depending the independent variables. With the use of independent variables, we can predict the future of your data. Regression analysis can be used to examine the strength and direction of the relationship between the variables and to make predictions about the value of the dependent variable based on the given set of values of the independent variables. So that means what happened? Next, used to examine the strength and the right direction of the relationship between the variables. For that cases, we are using the regression. You getting my point or not? Regression and also the correlation. Both. Correlation we are not using for the predicting cases. We have to find out the relationship between the variables. But in regression, what happened? Now we are using these techniques to predict the future values. Maybe it will be forecast values, or maybe it will be future demand, or equal the future. What is you can say a requirement, or for marketing cases you can say future demand, future sales, anything. So that for that cases, what happened? We have to use a regression. Also, it is a part of the future forecasting techniques also. Then third one is hypothesis testing. After you find out the mean values or average value, then you find out the regression value, then another analysis is required. This is the hypothesis testing. The statistical method of hypothesis testing enable to researcher to information about a population from a sample data. So that means what happened? Now hypothesis testing is depending on your sample size. Whether sample is less or whether sample is more. When it is less than 30, it is called the small sample. When it is more than 30, this is called the, what is? One is small sample, one is big sample, yes or no? So that means small sample cases, which testing is applicable, and more than 30 or big sample cases, more sample cases, which techniques is applicable. It includes formulating the hypothesis, gathering the data, then analyzing the data, determine whether not the theory is justified or not justified. So when you are going for the small sample or big sample cases, we can say that, or sometimes large sample. Small sample also we can get the large sample. Small sample cases, which type of techniques, which type of statistical techniques you use, and large sample cases, which techniques you are using. So in that cases, what happen? Now sometimes we can say small sample test, sometimes we can say large sample test. A lot of industry, including market research, clinical trials, and scientific research, they are using this type of hypothesis testing. Sometimes the small sample test, sometimes the large sample test. So major part is that if your hypothesis testing is depending on your sample size, now how can you determine the sample size? In the sampling technique also we are discussing about how to determine the sampling techniques. Sample size determination is a critical step in statistical analysis that determines the number of observations needed to accurately represent a population. So that means when you are designing your research or when you are designing your research study, so at that time we have to find out that whether your sample size is defined or not. If it is not defined, first we have to define it. How can you define it? Now you have to determination of your sample. Either your population size known or population size not known. Because two cases we can calculate the sample size. Either population known or population not known. Is not known, that is separate techniques to determine the samples. If population is known, that is a simple separate techniques to determine the sample. So many techniques are available. You can implement any one also. The sample size should be large enough to provide sufficient power to detect meaningful differences or relationships while being small enough to limit the cost of collecting data and the potential for false positive results. Collecting for false positive results. So that means whatever. Now sometime when you are using this sample size, sometimes the relationship between the samples are more, sometimes the relationship between the samples are maybe less. So at that time what happened? Now if your data collection or data you can say the relationship between the data is not more, the result should be not good, it should be negative. So that means what happened? Now when you collect the data or sample, when you collect the sample, so at that time your sample or your data, you can say data relationship should be required. Without relationship, if you are collecting the data as per not requirement at all for your the research work, that automatically what happened? Your result will be false or if the result will be negative. Then what are the benefits of statistical analysis? Why you are using this statistical analysis? Is it required? If it is required, then what is the benefits of statistical analysis? First one is the improved decision making. Improved decision making. By analyzing data, identifying patterns and relationships, statistical analysis help decision makers make more informed decisions based on empirical evidence. So when we are using the statistical analysis to using the various techniques, at that time what happened? Now you can improve your decision making. Suppose you cannot take the decision that whether our quality education should be more or not. You have not idea. Suppose you are being an entrepreneur, you have to find out that whether our education system is good or not. So for that cases, what happen? You have collected the data from the respondents or from the target audience. So after you collecting the data, if you analyze it, then only you can find out that whether our quality education is properly or we have to enhance the quality education. At that time, you have to take the decision. If not good, how it will be better, you have to take the decisions. Then second one is increased accuracy. Statistical method help to reduce the impact of random errors and provide more accurate results. So what happen? Now when you are using the statistical analysis, then automatically what happen? Now you have to increase your accuracy, increase your results, increase your solutions. So that means when you are using the statistical analysis, the benefit is to increase accuracy of your particular problem. Then better understanding of the data. Statistical analysis allow you to explore data in depth, identify trends and patterns, and uncover relationship between the variables. So, what is the better understanding of the data? We have to use the statistical analysis. Statistical analysis allow to explore data in depth of identify and uncover the relationship between the variables. So for that cases, we have to use the statistical analysis. We have to know that after collected the data, if data is not the same or the relationship between the data is not more, automatically you have to find out that your analysis decision or your analysis solution is not accurate. So that means you have to find out the uncover relation between the variables. Better communication of results. Statistical analysis provides a clear and concise way to present results and findings, making it easier for others to understand and utilize the information. Yes or no? So that means statistical analysis provides a clear and concise way to present results and finding, making it easier for others to understand and utilize the information. That means to better communication of the result, you can use the statistical analysis. So now question is that what is hypothesis testing or what is hypothesis testing in statistics? So if this is a benefit, then now we have to know that what is the hypothesis testing? Yes or no? Hypothesis testing is a type of statistical analysis in which you put your assumptions about a population parameter to the test. It is used to estimate the relationship between two statistical variables. Yes. When you are using hypothesis testing, so at that time what happened? Now you have to find out the assumption. Assumption means what happened? Now two type of statistics are assumption you have to take it. One is positive sense, one is not positive sense. Positive sense means that means what happened? Now sometimes we can say that in positive sense, we can say that this is a null hypothesis. Always it is accepted. Suppose that I am giving one example. How are you? The question is what? I am fine, I am bad. There are two questions in there. Sub question is more than two, but main question is either good or bad. Yes or no? If it is good, suppose that yes, you are good. So when you are answering your question that you are good, how can I know that you are correct? So you have to test it. So there is some parameters is there. This testing parameter is called null hypothesis. What? Suppose that you are good. So you have to ask questions from others, your family members. He is good or not? He is good or not? He is good or not? So if he is not good, that means what happened? He is not good. That means maybe bad. He is not bad. You cannot say that. He is maybe bad. So if you are testing a hypothesis, so always you are taking two assumptions. One is assumption is null hypothesis, and another assumption we are taking that this is called the alternative hypothesis. If he is not good, but he is good, is rejected. Suppose this statement is false. That means either bad, not bad. That means what happened? Now we are taking some conclusion. That is that what this is? Now first we have to use this formula. Formula is what? Now z equal to x bar. This is mean of the sample, or you can say sample mean. Mu o or mu 0 you can sometimes use that. This is the population mean by The sigma is called the standard deviation and n is called the sample size. So these four values is required to hypothesis testing formula. Either you can say go for t test or you can say the z test. Either small sample test or your large sample test. These two formula generally we are using in here. This formula, one is required value is mu or sample mean, x bar sample mean. Second one is mu or mu zero, the population mean. And standard deviation sigma is the standard deviation and n is the sample size. And use this formula and find out the values. Then how hypothesis testing work? How it will be work? An analyst perform hypothesis testing on a statistical sample to present evidence of the plausibility of the null hypothesis. Measurement and analysis are conducted on a random sample in the population of test theory. Analysts may a random population sample test two hypotheses. One is null hypothesis and that is alternative hypothesis. So in here what happened? The first one is that when you are using the testing of hypothesis, first you have to find out that what is your null hypothesis, what is your alternative hypothesis. This null hypothesis, this hypothesis we can find out from your objectives. After find out the objective hypothesis, then each hypothesis, there is a two alternatives or two assumptions we have to take it. One assumption is already discussed that this would be null hypothesis and another one is alternative hypothesis. Suppose that I am giving one example that any student you can say that the student scoring the marks in your coming examination is equal to 70 or 70 marks he is scoring from the examination in the examinations. So what is null hypothesis? Yes, it is true. He is scoring 70 marks in this examination. This is your null hypothesis. If statement is wrong, he is not scoring the 70 marks in the examination, then what is the alternatives? Either he is scoring less than 70 marks or he is scoring more than 70 marks. Again, two assumptions are there or not? Yes. But in here, if he is not scoring the 70 marks, this null hypothesis is wrong, then you have to find out again from your alternative hypothesis whether he is scoring less than 70 or more than 70. If less than 70, this is called left tail test. Later on we are discussing. This is called left tail test. If greater than 70, this is called right tail test. That means there are two type of test is there, hypothesis testing. One is left tail test, one is right tail test for the alternative hypothesis. Now discussing what is the null hypothesis and the alternative hypothesis. The null hypothesis is the assumption that the event will not occur. A null hypothesis has no bearing on the study outcomes unless it is rejected. So when you are taking your null hypothesis, the assumption is that the null hypothesis always accepted. Yes or no? And null hypothesis denoted as HO is the symbol for it. HO. Or sometimes we can say that H0, but exactly HO. Null hypothesis. The alternative hypothesis is the logical opposite of the null hypothesis. The acceptance of the alternative hypothesis follows the rejection of the null hypothesis. H1 is the symbol for it. Yes or no? So what is symbol for it? H1? This is called the alternative. If you are taking HO or H0, if H0 is the symbol of the null hypothesis, H1 is the alternative hypothesis. That means what happened? Now first we have to take that those hypotheses you are taking for your analysis, the logically it is true and accepted. If not accepted, logically it is not true, then we will go for alternative hypothesis. Denoted by HO or H0 null hypothesis, H1 for alternative hypothesis. Steps of hypothesis testing. Specify your null and alternative hypothesis. Second point is gather data. Third point is conduct statistical test. Fourth point is Determine acceptance or rejection of null hypothesis. Step 5 is present results. So that means what happened? This is one by one. In step 1, specify your null and alternative hypothesis. For any researcher or any investigator, you have to take your hypothesis from the objective, the first point. Second point is, from the hypothesis, again you have to find out what is your null hypothesis and what is your alternative hypothesis. If you are not specify or define your null hypothesis, alternative hypothesis, then what happens? You cannot take your analysis from the data. After you identify and specify your null and alternative hypothesis, then you go for your data analysis. That means you collect data or you gather the data. After collection of the data or gather the data, then we go for statistical test. Which statistical test is applicable in here? Either small sampling test or small test or your large test. Yes or no? Accordingly, you have to use the techniques. After you use the techniques, you have to find out that whether your null hypothesis or those hypotheses you have to take for analysis, whether it is accepted or whether it is rejected. If accepted, then what is your solution results? If not accepted, then what is your results? So when you find out the values of your analysis from applying for any test, then there are two type of value you have to calculate. One is tabulated values, one is calculated value. When you do calculation with the help of formula, which formula? The above formula. You have to use this one. And you have to find out the result. If this result is less than with your tabulated data is given in tabular form in your backside of the books, or any you can collect from the internal sources also. If less than, then only you can find out that your null hypothesis is accepted. If your calculation value is greater than tabulated value, then your null hypothesis is rejected. At that time, we have to consider the alternative hypothesis. So this is depending on your results. So after that, when you accept or reject your hypothesis, you can draw your conclusion. Otherwise, it is very difficult to find out the solution. Clear or not? Then, which type of test generally you are using in your hypothesis testing? So first one is small sample test. To determine the whether a discovery or relationship in statistically significant hypothesis testing uses a z-test. It usually checks to see if two means are the same, the null hypothesis. Only when the population standard deviation is known and the sample size is 30 data points or more can z-test be applied. Yes or no? That means what happened? Now we need the two. One is standard deviation and another is population size. It should be known. Then we can use the z-test. Sample size should be more than 30. Then only you are using this t-test. The formula is given and you have to apply here and you have to find out the solution. Then t-test is what? A statistical test called the t-test is employed to compare the means and two groups to determine whether two groups differ from each other or not, or if a procedure or treatment affect the population in test. It is frequently used in hypothesis testing. So generally, when you are using the t-test or software, so testing hypothesis, generally you are using the t-test. Yes or no? So same formula it is given at some z-test and t-test both are same formula. Which formula? Z is equal to mean x bar sample mean minus population mean divisible by standard deviation by square root of n. This formula we are using for both z-test and t-test. Then only you can find out the solution. Then another one is chi-square test. Chi-square test sometimes also we are using for testing hypothesis. Generally it is a non-parametric test and sometimes we are using this one for testing hypothesis whether your hypothesis is accepted or rejected. So chi-square test the hypothesis testing concerning whether your data is predicted. To determine if the expected and observed results are well fitted, the chi-square test analysis the differences between the categorical variables from random samples. The test fundamental premise is that The observed values in your data should be compared to the predicted values that would be present if the null hypothesis are true. If the null, that means generally what happens, the statistical case, we have to use that some specific variable cases we are using the chi-square test. That means what happens? Now, when you are unable to find out the relationship between the variables. For example, we are giving one example. Suppose that. So we have to find out the solution that which age group students are consuming more cigarette. For one example, which age group students are consuming more cigarette. That means what happened? The two variables are there. One is age, one is cigarette. In this type of situation, generally we are using chi-square test. So that means what happened? Whether which age group students are consuming more cigarette. So we can easily find out this one, and accordingly we can give the suggestion to the others. Right? So in these three cases, when are using the testing approach, one is Z test, one is T test, and one is chi-square test. So after that, when we calculate the values, from this test, and when you compare with your tabulated value for the acceptance or the rejection of the hypothesis, at that time what happened? Now we need some values. One is confidence interval, one is that is called level of significance. These two is very, very important. Without help of confidence interval and without help of your level of significance, we are unable to find out the tabulated value from the table. So these two is very, very important. So what is hypothesis testing and confidence interval and level of significance we are discussing now. Now, both confidence interval and hypothesis are inferential techniques that depend on approximating the sample distribution. Data from a sample is used to estimate a population parameter using the confidence interval. Data from a sample is used in hypothesis testing to examine the given hypothesis. We must have a postulated parameters to conduct the hypothesis testing. That means what happens? In which level, 5% or 10% or 15% or 100% interval we are taking the values. And this interval generally whatever, when the formula we are using Z values. So at that time we use this one. So in the use of continuous intervals, this value is given. 5% what is the level of intervals, 10% what is the level of intervals. Accordingly, what happens, now when you are find out the values from the table values, so at that time the basis of the confidence interval, the value is given, and this value is called the probability value, the chances value. Sometimes we can say that what should be the probability values of this test. Yes or no? And this probability value also sometimes what we can think about that this is the level of significance, the help or depending on level of which level of significance the value we are calculating. Next one is one-tail and two-tail hypothesis testing. In a one-tail test, the critical distribution area is one-sided, meaning that the test sample is either greater or lesser the specific value. In two tails, the test sample is checked to be greater or lesser range value in the two-tail test, implying that the critical distribution are to be two-sided. If the sample falls within this range, the alternative hypothesis will be accepted and the null hypothesis will be rejected. This is. So in a one-tail test and two-tail test means what happens? In simply we are discussing that in one-tail test and two-tail test. In one-tail test, the critical distribution area is one-sided, either your left side or your right side. That means suppose that I am giving an example that your monthly income is less than 100. That means the null hypothesis what happened? The null hypothesis is less than 100. Alternative hypothesis more than equal or more than 100. If equal sign is there, so this is both side it will be distributed, left side and your right side. But greater than is given, this is the right tail test. One-sided right tail test. Is less than is equal. This is left tail test. But equal is given. Here that is income is equal to 100. So if equal is given, means this is both sided it is given. So that means one tail test and two tail test. Generally in hypothesis testing we are using, yes or no, to find out the value of area value of the data. Right to test hypothesis testing, what happens if the larger than greater than sign is given. The sign appears in your hypothesis statement. You are using a right tail test, also known as the upper test. Or to put in another way, the disparity is to the right. Example I am giving one here. You can contrast the battery life before and after a change in production. Your hypothesis statement can be the following. If you want to know if battery life is larger than original, let's say 90 hours. So that means what happened? Null hypothesis is H0 either less than or equal to, because what happened? It is given that. Statement can be following that if you want to know the battery life is larger than original. So if you are less than or right, possibility is that battery life is risen H1 greater than, if your null hypothesis either you can take less than equal to 90 hours, less than equal to 90 hours. So alternative should be more than 90 hours. Yes or no? So that means what in here what happened? The null hypothesis is 90 hours or less than equal to 90 hours. That means your alternative hypothesis should be more than 90 hours. You cannot then equal to 90 hours or less than 90 hours. If your null hypothesis is less than 90 hours, then your alternative hypothesis will be equal to greater than 90 hours. You are getting my point or not? Because when you are taking, when your sign is greater than the right test, but if equal is given, we cannot say this is right test. So only when it will be greater, not equal is there. If greater than 90 hours, then only we can say that this is your right test. This is a good example. So what is your left tail test? Similarly, only less is there. Then we can say this is your left tail test. If less than equal to is given, we cannot say this is the left tail test. Only the sign is left. Alternative hypothesis that let's say the rule level of parameter is lower than the null hypothesis are tested within the left tail test. They are indicated by the asterisk or less than. Example, suppose HO or mean equal to 50, H1 mean is not equal to 50. According to the theory or hypothesis rules of hypothesis, H1 the mean can be greater than or less than 50. This example of two tail test is that in a similar manner, H0 if mean greater than equal to 50, then mean less than 50. Here the mean is less than 50 is called the one tail test. Yes or no? So when your mean is less than, suppose question is given that your null hypothesis is greater than equal to 50. Your null H0 is greater than equal to 50. Then what do we alternative hypothesis? Alternative hypothesis is less than 50. It is mentioned that H0 null hypothesis mean equal to greater than equal to 50. So if mean value is greater than equal to 50, then what will be the alternative hypothesis? Alternative hypothesis less than 50, and less than 50 is called the left tail hypothesis test or left tail hypothesis testing. Here the mean is less than 50, it is called a one tail test. But we are not writing in here one tail test, left or right? Now left tail one tail test. Left tail one tail test. If sign is greater than equal to greater than is given, not equal to. If greater than is given, we can say that this is right tail hypothesis testing or right tail hypothesis test. Right tail one tail test. Listen. Then, so after your null hypothesis, alternative hypothesis, left tail test, right tail test, or two tail test. After that, we have to calculate it. What is type 1 error and type 2 error. This is very, very important. Your null hypothesis, alternative hypothesis, or your hypothesis testing fully depending on your type 1 error and your type 2 error. So what is type 1 error? Type 1 error occurs when sample errors reject the null hypothesis desired to be true. Or alternative, we can say that If null hypothesis is accepted, alternative hypothesis is rejected, then we can say that this hypothesis is a type 1 error. Remember this one. If null hypothesis is accepted, alternative hypothesis is rejected, then we can say that our null hypothesis or our hypothesis is type 1 error. Similarly, type 2 error what? A null hypothesis is rejected, alternative hypothesis is may accepted, then we can say that this is a type 2 error. But in the recurring definition, what happened? A type 2 error occurs when the null hypothesis is not rejected, when it is false, unlikely type 1 error. So that means what happened? Null hypothesis not rejected. We have to not accept it. So if it not accepted, we cannot reject this one. If null hypothesis not accepted, if not accepted, we cannot reject this one. May accepted, then only we can say that type 2 error. Null hypothesis type 2 error. Yes or no? So simply what you have to remember this one. Type 1 error, null hypothesis accepted, alternative rejected. Null type 1 error. Null hypothesis is not accepted, alternative may rejected. Then we can say, then we may accepted, then we can say that this is a type 2 error. One example we are giving, suppose a teacher evaluated the examination paper to decide whether a student pass or fails. What is your H0? Student has passed. What is your H1? Student has failed. If not passed, failed. Type 1 error will be the teacher failing the student reject H0. Although the student scored the passing marks, H0 was true. This type of, that means what happened? Null hypothesis is true, alternative hypothesis rejected. It is given or not? Type 2 error will be the case where the teacher passes the student, do not reject. Yes or no? That means not accepted, but do not reject. Although the student did not score the passing mark, the H1 is true. So that means what happened? Now this is type 1 error and this is type 2 error. And simply we can say that student passed or null hypothesis accepted, alternative hypothesis rejected. This is called type 1 error. Null hypothesis not accepted, alternative hypothesis may rejected. This is called type 2 error. The level of significance. The alpha value is a criteria for determining whether a test statistics is statistically significant. In a statistical test, alpha represents an acceptable probability of a type 1 error. Because alpha is a probability, it can be anywhere between 0 to 1. Probability value always 100%, 0 to 100%. So that means probability value, we are taking 100% means 1, 0% means 0. In practice, the most commonly used alpha values were 0.01, 0.05, and 0.01. That is one level of 1% level of significance, 5% level of significance, or 10 level of significance, and the rejecting. So that means what happened in the type 1 error, in the type 2 error, what happened when you are using these techniques? So generally, always we are taking the values in percentage case, percent wise. 0 to 100% means either 10% or 5%, 1%. Because why we are taking 1%, 5%, 10%? Easily we can calculate the values from the table values. But we can say 1%, 2%, 3%, 4%, 5%, 10%, 100%, 50% like this. Everywhere you can find out these values. 1 to 50% values, same as 50 to 100% values. So that's why it is given there 1%, 5%, 10% like this. You can find out values. Probability value or significance value, we can say that. P value is a metric that expresses the likelihood that observed difference could have occurred by chance. As the P values decreases, the statistical significance of the observed value increases. If P values is too low, you reject the null hypothesis. That means what happens? Now, if your significance value is less than 0.5, then you reject the null hypothesis. If it is more than 0, we accept the null hypothesis. This is the P value and level of significance level of the data. So we have to find out that whether your null hypothesis is rejected or you are accepted. Why is hypothesis testing important for research methodology? Provides evidence-based conclusion, already discussed. Support decision making, already discussed. Regression and validity, yes. So when we are going for testing hypothesis, your data set or your conclusion, statistical evidence. So this is what it is true or not, it is valid or not. In a scientific rigor to research using statistical methods to analyze data, ensuring that conclusions are based on sound statistical evidence or not, and contribution to advancement of the knowledge. All of you know, when you are doing any research work and when you are that is practicing any research work at that time, what happened? Now, here you have developed your knowledge. The limitation. It cannot prove or establish the truth, right? Hypothesis testing provides evidence to support or reject a hypothesis, but it cannot confirm the absolute truth of the research questions. Results are sample specific. Hypothesis testing is based on analyzing a sample from the population and the conclusions drawn from specific so that particular sample. Possible error, yes, sometimes what happen, error may be occurs. Possible error should be less. So when you are using the hypothesis testing, your error should be X. During the hypothesis testing, there is a chance to committing type 1 error, rejecting the null hypothesis. Type 2 error, failing to reject the null hypothesis. And next one is assumption and requirements. Different tests have specific assumptions and requirements that must be made to accurately interpret the result. So this means what happen? Now, when you are using any research work, so at the time when you are using the testing hypothesis, so you have to find out the accurate interpret results you can find out. Then parametric and non-parametric test. So when we have to find out that why the testing hypothesis is important. So what type of test generally we are using for our research work? One test is parametric and another is non-parametric test. So generally in the student level, or you can say that in academic level generally, when you are doing your research project or when you are using your summer project, at that time what happens? Generally you are using the parametric test. Parametric tests are those tests for which we have prior knowledge of the population distribution. If not, then we can easily approximate to the normal distribution, which is possible with the help of the central limit theorem. That means what happens? Those formula we are giving that z equal to sample mean minus the population mean divisible by standard deviation by square root of n. This technique we are using for the parametric test, and we have to use the z and t state values, and we want to find out the solution. But some cases what happen, we are unable to use the parametric test to find out the solution. So at that time we have to use the non-parametric test. Suppose the sample size is more variables are there. So at that time we are not able to use the parametric test. At that time we are using the non-parametric test. So in non-parametric test, we do not make any assumption about the parameters for the given population or the population we are studying. In fact, these tests do not depend on the population. Hence, there is no fixed set of parameters is available. And also there is no distribution, normal distribution is there. Any kind is available for the if. That means in non-parametric test, what happens? There is so many variables are there. So we cannot find out the any one parameter. So for that cases, what happens? Now besides the parametric test, we are using some non-parametric test techniques we are using, and we have to calculate the values in the basis of the what is hypothesis test. So now we are discussing about that some parametric test and some non-parametric test. What are the parametric test? What happen? Now there are some test is there. One is T test, or sometimes we can say the student T test. And the T test is a parametric test. Z test, this is a parametric test. F test, or we can say the ratio test. This is also a parametric test. And ANOVA, analysis of variance. This is also parametric, but sometimes we are using this is a non-parametric test. Chi-square test, chi-square test, and the analysis of variance test. Some researchers or somewhere we are using for parametric test, and somewhere we are not using the parametric test. This is a non-parametric test. But most of the researchers now they are using these techniques, the four techniques. This is generally we are using for the parametric test. And another one is non-parametric test types. That is one is chi-square test, Mann-Whitney test, U test, and Wallis S test. These are generally called the chi-square test. So chi-square test, what happen in here? Now there is a more variables are there. and what is more parameters are there, generally you are using in here. That means what happen? Now when you are using the parametric test and non-parametric test, first you have to find out that what is your hypothesis. What should be the parameters you are taking from your hypothesis? As per the parameters, we have to take whether it is a parametric test and whether it is a non-parametric test. Beside in the non-parametric test, what happened? Another techniques also we are using. This is called multi-dimensional scaling techniques. If the parameters is too many type of parameters are available, we are unable to test the data in the basis of parametric test and the non-parametric test. So for that point of view, what happened? We are using multi-dimensional scaling techniques. So many techniques are available. All parametric and non-parametric tests are available. In the basis of we can use which technique is available for your data analysis. Accordingly, you have to use this one. So we can say that there the correlation analysis, the regression analysis, factor analysis, determinant analysis, conjoint analysis, multivariate analysis, and sometimes we can say structural modeling also. So these are called the multivariate techniques. Later on, we are discussing all the techniques. And for today, this is your topics. How we can calculate your data sets by the testing hypothesis with parametric test and non-parametric test, and what is the uses of statistical techniques we are using for testing hypothesis. Thank you. So thank you all.